Question number 1. Find the area of the region bounded by parabola y equals to 5x squared, the tangent line to this parabola at the point 1, 5, and the x-axis. Okay, that's me. First of all, let's draw a graph. Parabola and tangent line and the x-axis. Okay. Or actually, we can try to find a tangent line. That's me. Tangent line is at the point 1, 5, has the equation. I will use the point slope equation, y minus y1, slope x minus x1. That means my point is 5 and 1. I mean y is 5, x is 1. And then we need slope, but slope is simply a derivative of the function. That means derivative of this parabola, it's 10x, and derivative at the point 1 is 10 times 1, of course 10. I will write this way. Okay, that's when we have y minus 5, 10 is a slope, x minus 1. I will distribute 10x minus 10, and adding 5 to both sides of the equation, I will have 10x, negative 10 plus 5 is minus 5. This is a tangent line. Tangent line. Of course, at 1, 5. Okay, that's now we can draw it. This tangent line, we can see that if I would like to find the x-intercept, it's 1/2. Because 10x minus 5 equals to 0 if x is half. That's when we do have an x-intercept. Okay. That means I will draw this situation, and then we will try to find an area. Okay, that's we have parabola. It's a little bit slimmer because it's 5x squared, but okay. And then we need a tangent line. I will draw it like that. Okay. Or maybe we're not fully satisfied. Okay, this one looks better. That means this is parabola 5x squared. That's the tangent line. 10x minus 5. This is point 1/2. That's of course 0. And this was 5 and 1. Okay, now we're looking for the area of the region bounded by parabola. Tangent line, that means I can draw it. Parabola, tangent line, and the x-axis. That means the situation is a little bit challenge. We have to be careful. That's what we will do. I can see that from 0 to 1/2, I will have that part. And the blue part, I can name 1. The area of the blue part will be defined as an integral from 0 to 1/2, and the top function, of course, is parabola 5x squared minus, we don't even have to write 0, but I can write. It's basically the definite integral, because definite integral represents the area under the curve above the x-axis. But since we're talking about the area between two curves, I have my subtraction. Okay, and I can possibly compute this. Integral of 5x squared is 5x cubed over 3. Of course, we're ignoring 0, and we have to evaluate from 0 to 1/2. Substituting 1/2, we will have 1/2 to the power of 3 is 1/8. And substituting 0, of course, we have 0. That means this integral is 5 over 8 times 3, 24. Okay, but now let's see, we do have another part of the region from 1/2 to actually 1. Okay, that means my purple region is defined as an integral, definite integral from 1/2 to 1. The top function is 5x squared minus the bottom function, which is the tangent line, 10x minus 5. Everything with respect to x. Okay, and I will evaluate this integral and I will add these numbers together. Let me rewrite one more time because we do have a negative sign. 5x squared minus 10x plus 5. Okay. Integral of 5x squared is 5x cubed over 3. Integral of 10x actually is 5x squared. And then integral of 5 is 5x. Everything from 1/2 to 1. Okay, let's see. If I substitute 1, I will have 5 over 3 minus 5 plus 5. And substituting half, I will have half to the power of 3, which is 1/8, the same like we did in the first one. Half squared is 1/4, that means 5 times 1/4, and 5 times half. Okay, I can see this, that's what I will have 5 over 3. This will be 5 over 8 times 3, 24, and I'm changing the sign. This negative will become also positive, 5 over 4, and then this will become negative, 5 over 2. Okay, the only thing is that now I can, the total integral, okay, the total, the whole area, actually I can write area, okay, it's simply the first one plus the purple one. Okay, and I will use the red. That means the first one was 5 over 24, and then the second one was 5 over 3 minus 5 over 24 plus 5 over 4 minus 5 over 2. I'm just doing this because I'm not happy to add all of these fractions together. I mean, probably I have to, but I can at least cancel out this one. That's what I realize. Okay, 5 over 3, 5 over 4, 5 over 2. I believe the common denominator is 12 times 4, and then 12, 3 times 3 is 15, and 12 to 6 times 5 is 30. Am I right? I multiply by 6, okay? Because always the easiest part is the most challenge. 20 plus 15 is 35, not 25. 35 minus 30 over 12. This means the final answer looks like 5 over 12.